Hello everyone, my name is Jitasmita Banerjee. I am from Computer Science and Engineering Department, 3rd year, and I have created a temperature monitoring and alert sending system using Internet of Things, also abbreviated as IoT. So first let's discuss about all the materials that I have used for creating this project. And in that I'm first going to specify all the hardwares required. So I've used the temperature sensor, which is an LM35 sensor, and then I have used the Bolt Wi-Fi module. I have used 3 male to female jumper wires that will actually help me to connect the sensor to my Wi-Fi module. I have used a micro USB charging cable that will help me to provide power to my Bolt device. And the 5th thing that I've used is basically my laptop, and that is used for providing the power supply to my Bolt device as well as for recording the data that is being detected using the sensor. Now let's jump on to the software specifications. So as you can see, the first thing that I require is the Bolt Cloud, which is going to help me to set up my device and also to configure my device. Then I need a Twilio trial account. Now Twilio will actually help me to send alerts through SMS. So I need to sign up and create a trial account, which is basically free. And it's going to provide me a demo number from where I can receive the SMS alerts. And then we need to write some code in Python programming language, and for that you will require any code editor or IDE of your choice. And I have used Jupyter Lab. And then we need to do the coding in these 2 languages. First is going to be JavaScript and then it's Python. So now let's come to the working of the sensor. So why are we using an LM35 sensor? It is basically a temperature sensor that detects the surrounding environment's temperature, and then it's going to generate the analog output voltage. This output voltage that is produced by the LM35 sensor is given as an input to the Bolt Wi-Fi module's A0 pin. Okay. Now then the Bolt device is going to convert this analog value to a 10-bit digital value, and this digital value will actually be sent through the Bolt device to the cloud and the platform. Okay. So let's come to the working of the sensor. So this is a basic image of the LM35 sensor. So as you can see from this image, it is a 3-legged device, and the 3 pins or the 3 lengths are namely, the first one is going to be for the supply, also called VCC pin. Next one is going to be for the output, and the third one and the last one is going to be for the ground. Okay. Now it functions on the logic that when the ambient temperature of the transistor is going to change, the current flowing through it will also change. And it has many transistors and several amplifiers which are packed in a small space, which enables the conversion of this current to voltage. And that is why we get the output in terms of voltage. Now what is basically the logic? When the voltage across this sensor increases, the temperature increases and vice versa. So when a higher voltage flows across this sensor, a higher temperature is going to be noted, and when a lower voltage flows across this sensor, the temperature noted will be a lower temperature, and in this way we can calculate and plot the temperature fluctuations. So the temperature fluctuation can be detected with respect to the change in the voltage across this sensor. So as you can see, this is the basic circuit diagram. Now you might be thinking that since we need to convert the current into voltage, we should be using an external voltage divider. Now we don't need to explicitly use any voltage divider in case of the LM35 sensor, because it has some inbuilt voltage divider which actually does the work. So it directly calculates the voltage with respect to the current, and therefore it interfaces directly that value to the analog A0 pin. Now this LM35 sensor can measure temperature between the range of -55 degrees Celsius to 155 degrees Celsius, and that is basically a wide range of temperature that should suffice our most of the circumstances and purposes. So as you can see, this image is basically of the LM35 sensor that I have used in this project. Now you might be thinking that since the output that we are getting is in voltage, but we need the output in temperature because that is what we need to plot on the graph, then how is this conversion going to take place? So the conversion takes place using this formula that you can see on the screen, and that is basically T equals R by 10.24. So here T is the temperature in degrees Celsius, that is basically the output that we want, and R stands for the reading of the sensor, that is basically the voltage. So the voltage is going to be converted to temperature in degrees Celsius using this formula. Now let's discuss what is the main objective of this project. Our main motive is to record the temperature of the sensor and also to plot it in a graphical format to visualize the temperature fluctuations. So the sensor is going to help us to detect the temperature of the surrounding region, and whatever data that sensor is going to read is going to be plotted using the code that we are going to write on the Bolt platform, and that code is going to be in JavaScript. So what we are going to do, using some lines of simple JavaScript code, we will be actually plotting line charts that will help us to visualize graphically the data that is being detected using the sensor. So this is the first part of the project, and the second part of the project is about sending SMS alerts whenever the surrounding temperature is going to cross the minimum and the maximum threshold. So we need to explicitly define the maximum and minimum temperature threshold in our Python code, and based on that, whenever the surrounding temperature increases above the maximum threshold or falls below the minimum threshold, it's going to send SMS alerts to the registered phone number. In that way, the person who is registered to receive the SMS will be alerted as soon as there is an unnatural temperature fluctuations that is not wanted. So these are all the materials that I have used for this project. You can see the Bolt Wi-Fi module. Then this is my LM35 sensor, which is the temperature sensor. Then we have used 3 male to female jumper wires, and this is the micro USB charging cable. And this is the final built product. And this is how the plotted graph looks. So once the product has been built and it has been configured properly and the configuration has been deployed, we will be able to get this kind of a graph where at each and every time instance we are plotting the value that is being read by the temperature sensor in this line chart, which helps us to monitor the fluctuations of temperature. And this is also the snap of all the SMS alerts that I've received on my mobile phones. As you can see, it says that it has been sent from the Twilio trial account, and at each and every time instance it gives me what is the current sensor value. So this is basically the sensor value that is recorded by the LM35 sensor. Now let's come to the real life usability, which explains that where is this project going to be useful in real life. So every year, the biopharma industry loses approximately $35 billion annually due to failures in temperature control logistics. Billions of dollars worth of pharmaceutical products are stored and shipped at improper temperatures. And this often happens due to improper storage and handling and careless attitude of the people who are involved in the storage and manufacturing process, and also the usage of some backdated old school mechanisms and machines that do not provide real-time visibility and also don't possess an efficient alerting system. So all of these machines, they cannot efficiently read the data in real time, and also they are not that much equipped that they can immediately and efficiently alert the required people whenever there is some uncanny behavior. So this leads to inefficacy of the medicines and drugs, wastage of millions of blood samples, and also other biological commodities. So this incurs a huge loss, not only on the economic level, but also on the biological level. So with the Bolt temperature monitoring and alert system that I have created, the real-time data can be accurately read, plotted, and graphically represented with safe and secure storage of the data on the Bolt cloud. Also, the alert sending systems through emails, SMS, and other methods lets the people have a peaceful night's sleep without worrying about the improper conditions that might be happening at the storage places. So let's discuss the utility. The sensor will sense the temperature data, and the Bolt cloud will help to connect our Bolt device with the software configurations, thereby effectively plotting the data in real time. And we are also using Twilio, which is basically an American cloud communication platform as a service company, and it helps us to send alerts in the form of SMS to the registered phone number by connecting our Bolt device with our account by just writing few simple lines of Python code. So all of this ensures real-time effective monitoring of the temperature and also sending immediate alerts as soon as the temperature crosses the threshold value. And therefore, huge losses, both at economic as well as biological levels, can be avoided by using our Bolt device. So now that we have discussed the real life usability, the utility, and also all the requirements for this particular project, let's move on to the hardware configuration part.
Okay, so welcome to the hardware configuration part. So first I'm going to show you all the components that I will be requiring to create this device, and then I'm going to show you the step-by-step procedure of configuring this or creating this device. Okay. So first are the components that I will be requiring. So the most important thing that is here is the LM35 sensor. So that is basically a temperature sensor, and it is a three-legged device as you can see, and it has got three legs. One stands for the supply, one is the output, and one is the ground pin. Okay, so I need to hold this sensor in such a way that I can see the LM35 word written. So it's actually we are going to hold it in this way, and in this order. This one is the supply pin, this one is going to be, the middle one is the output pin, and the third one is going to be the ground pin. Okay, so I hope you can see. So this was the first important component. Next is going to be obviously our Bolt Wi-Fi module. So that is basically the module or the main chip that we are using in this case. And the next thing that we require is three male to female jumpers. So these are the three jumper wires that I will be needing to connect the sensor to my Wi-Fi module. And last but not the least, to provide power to my device, I will be requiring a micro USB cable, that is this one right here. Okay, so I need to connect this with my Bolt Wi-Fi module, and then I will be inserting this into my laptop from where it will be deriving the power it requires to run. Okay, so now I need to show you how to create or what is going to be the circuit configuration for this product. Okay, so I've already told you that I need to like hold the LM35 sensor like this so that I can actually read LM35 being written. So first is I need to connect the supply pin, which is also called the VCC pin, to the 5-volt port in my Wi-Fi module. Okay, so I will be actually taking one male to female jumper wire, and I need to insert this properly in the supply pin, and I will insert this in the 5-volt section like this. Okay, so you can see that the supply pin has been connected to the 5-volt section. Okay, next we have our output pin. So for that, again I need to take one male to female jumper wire, and I will connect the output pin to the A0 port of my Wi-Fi module. Okay, so I will connect the output pin to the A0, which is basically the analog 0 of my Wi-Fi module. Okay, so I hope you can see the readings. Right, and last we are left with the ground pin of the LM35 sensor. So I need to again take one more male to female jumper wire, and I need to insert this in the third leg of the LM35 sensor, and I need to insert this in the ground port of my Wi-Fi module. That is all. Okay, so this is the final connection. I hope you can see. So I will use my USB cable, and I will connect this to my Bolt Wi-Fi module, and now this is connected. All I need to do is I will just insert this in my laptop. Okay. So now my device is ready to be powered up. So all I need to do is I'm going to take the USB cable and I just need to insert this into my laptop, and now you can see that the power supply is available. Now you can see that both the blue lights and the green lights have lighted up, and this ensures that the power is being properly supplied to my Wi-Fi device, and also it has properly connected to the Wi-Fi. Now once this hardware configuration is completed, we can jump over to our Bolt Cloud to configure this device and deploy the configuration.
So now that we have seen the hardware configuration of this particular device, and we have also discussed what is going to be the real life application of this device, we are now ready to set up the device. So all I need is my Bolt Cloud account. What I need to do is I actually need to come inside my products tab, and here you can see that I actually have a list of the products that I have created with my Bolt Wi-Fi module. So now we are concerned with the temperature monitor, so I'm actually going to click on that. Okay, and the first thing is I need to link this particular product with my Bolt Wi-Fi module. So how to do that? We actually have this option which says link device to this product. So I'm just going to click on that, and it's going to show me the available Bolt devices, and this is the one on which I am working currently. So I'm just going to click on that and then click on done, and then I will click on yes, and it is going to show me that this device has been linked with my Bolt Wi-Fi module. So you can see that this is basically my Bolt Wi-Fi module on which I'm working currently. And what I need to do is I need to make sure that the analog A0 pin is connected, and the variable name is basically temp, because that is the variable that we will be using in the code for this particular product. Okay, so you can see that this is the code which I'm using here, and that is basically a JavaScript code. I've set the file name as temp monitor, and what I'm essentially doing is I am taking the help of the Google chart library that will actually help me to create the chart, the line chart, where we can properly plot the data that the sensor is collecting. And I'm just going to save this. I'm finished. What I need to do is I need to deploy the configuration which says view this device. So I need to click on that, and what is going to happen? A new tab is going to open up, and so as you can see that I have started the reading with this device on November 10th, that is basically today, and the time was 5:42 minutes 11 seconds, okay, PM. And then the temperature actually was 27, right? And now you can see that since we have set the data collection time to 5 minutes, so after every 5 minutes we are going to get a new data, and that is going to be plotted on this graph using Jupyter Lab for this particular project. And this is basically the entire code that I have written. So if you carefully notice, the first part is basically all those details that we will be getting from our Bolt Cloud as well as our Twilio account. So in this case, it's very important that how you set the maximum and the minimum value, right? So what I need to do is I need to run this code. You can see I am getting the output right here.
Okay, so I'm constantly receiving the SMS alerts from the Twilio free account, and as you can see, I'm getting the SMS alerts automatically. Okay, so it's telling me that the current temperature is 277, and this SMS has been sent from my Twilio trial account. Okay, so in this way, I'm going to be alerted every time the temperature is above the threshold or below the threshold. So if any person who is outside or who is in a remote place, and I need to alert that person that yes, the temperature has gone above the threshold or it is below the threshold that is not in the optimum level, that person can very easily be notified with the help of these SMS alerts that we have sent from our Twilio trial account.